Hi everyone, let me discuss about the Bootstrap Loader in this session. The Bootstrap Loader is one type of system software. It is also a type of absolute loader, which is used to load the operating system into the memory. So when you have the Bootstrap Loader, so it is used to load the operating system into the memory. When we have the Bootstrap Loader program, so initially we have the statement like boot start 0, which means that the Bootstrap Loader by itself will be stored in the location 0. That's what whenever I was telling you about the user program, whether it is a SAC or SAC program. So when there was a starting at as 0, which is mentioned for SAC program or SAC program, there might be program relocation because the starting at a 0, which cannot be assigned to the program at the time of loading, because Bootstrap for the Bootstrap loader, the address is given, so that address cannot be given to the other program. That is the reason there might be there should be the program should be relocated into some other location. So when you start with the program, initially the accumulator register will be cleared. It will be assigned to 0. Then we have the X register, which is initialized to hash 128, that represent actually the hexadecimal value 80. And we have the JSub. JSub is nothing but the jump to the subroutine. So in the Bootstrap loader, we have a subroutine called getC, which is to be called. So from this program to another program wherein the getC function has to be taken place. To that program, the control is transferred. So when we call the getC function automatically, what happens? It reads the character from the object program, so which is actually to be loaded into the memory. So basically, the purpose of the loader is bringing the object code to the memory. That is loading the object code into the memory in the proper place. So when you call the JSub, when you call the getC subroutine, it is used to read the character from the object program, and that needs to be loaded. So it reads a character and that will be stored in the accumulator. So the accumulator has the character now. So from the accumulator, so that character has to be stored in the S register. So we have 9 registers in SACXC. The S register and the T register, these are the 2 registers which is used in the general purpose. Which is used as a general working registers. So whenever there is a data movement, for that purpose, we use the S register or the T register. So here we use the S register. From the accumulator, the data is moved to the S register, for which we use the instruction called RMO. So register movement. So the data is moved between the registers. So now what happens? Shifting the higher order 4 bits. So from the lower order, it has to be shifted to the higher order bits, 4 bits, because when you read a character which consisting of 4 bits, okay, shift L we use in the S registers to move to the higher order bits. Then we have the JSub. Once the first character is read, then again the second character has to be read. So getting the next digit, hexadecimal digit, we call again the getC function. When we have the getC function, now the character will be stored again into the accumulator. So now again one more character will come. So the previous character we already shifted or moved to the S register. Now what we do, we call the instruction set add R. So add R is an instruction set when you do the arithmetic operation between the content of the registers that time. So when you are involving only the registers, that time add or suppose if you are doing other arithmetic operation, then similar to the operation what we opted, accordingly the different instruction set will be used. So herein we call the add R so that the content of the S register and the A register will be added, and the result is stored in the second register. See here, the first register is S and the second register is A. Once the content are added, so we combine the two digits to form the single byte. See, when you read a character, the character will be 4 bits. So one character is there in the S and another character is there in the A. So 4 bits here, 4 bits there we have. So we combine this together so that it is forming 1 byte. So now what you do is store this into the X register. So we want to store the content, the result into the X register. So in the X register, where exactly the location is mentioned by the X register, in that place we store the content of ASTC, which basically storing a character which is there in the accumulator. So accumulator has the result of A and S because when you use add R, R1 is the S register, R2 is the A register. So the result will be stored in the R2 register. So this cannot be A comma S because the resultant should be in the A, because when you use STCH, the character which is stored in A should be moved. So that is why A should have the resultant. That's why S comma A should be there. So STCH will be storing the content from the accumulator to the location which is mentioned in the X register. So what is the address which is mentioned in the X register? To that it will be stored. So what is mentioned in the X register? Initially we make the register so we assign the value, hexadecimal value 80 to the X register. That is the location meant for the operating system. Now what will happen is you'll be incrementing the X value by 1. So when it goes to the next byte, so the X value has to be incremented. That is why, so when you move on to the next character, so that has to be stored in the next byte address. So for which we use the TAX instruction set. Since we increment the X value, the register value, so we are using TAXR and comparing with the X only. So TX is basically an instruction set which is used to increment the any value by 1. So here the X value by 1. And we have the loop jump to the loop. So the loop will go to the location where it calls again the JSON. So now once the address is incremented, location is incremented. So in that location, the other byte has to be stored. So for which again the getC subroutine should be called, and the same procedure will be followed. So till we have input in the object program, this process will be keep on repeating. When the getC function is called, what is the procedure is to be followed in the getC function? that is given in the program. So now you look at the getC subroutine. This is the program for the getC subroutine. In getC subroutine, the first statement is TD input. So TD is basically testing the device. So what is the input? Input is mentioned as in the hexadecimal F1. So this is a code for input device. So input is defined here with byte. So we assign in the code F1 that is representing the input device to the label called input. So when you test the device, exactly it is testing the input device. So here the test device it is used to test the input device for its availability, whether it is ready or not, that will be checked over here. If the value of the condition code is less than, then it is ready. If suppose the value of the condition code is equal to, then it is not ready. If the input device is not ready, then what needs to be done is it's keep on testing the device. We have the statement JQ getC. So when the condition code is equal to, jump to the getC. So the JQ is meant for jump if the condition code is equal to. When the condition code is equal to, has the value equal to when the device is not ready. If the device is not ready, then we cannot read the data from the device. So in order to get or in order to read from the input device, the device should be ready, for which we have to put in the loop. If the condition code is less than, automatically it goes to the next statement, wherein we have the RD. So RD is the instruction which is used to read from the input device and store the value in the accumulator. That's why again we make use of the accumulator. When in the previous program in the Bootstrap Loader is been called, so from the main program it calls the subroutine. So when it calls the subroutine, it takes the value character in the accumulator. That's why when you read the input, it is taking from the input device and storing in the accumulator. Now what happens here is the value will be compared with the value 4, that is hexadecimal value 4. So 404, the hexadecimal character 04 is representing the end of the file. When you compare the value, the A value with the end of the file, that's nothing but hexadecimal 04. So whatever the content which is present in the accumulator, which will be compared with the value which is mentioned in the constant. So that is nothing but 04. So that represents the end of file. So it's nothing but in the if we reach the end of the file, then no more inputs are available. So how it will be identified? When you compare, the condition code has the value. If it is equal to, if the both are equal to, then the condition code will be having the value equal to. So in the jump instruction, what we do again, J equal, which means that jump to the 80th location. So what for this has to be given here is, so when we reach the end of the file, then there is no more inputs. So which means it is end of the process. The process is done. The loading is done. The next step is to start the execution. So in order to start the program, so we need to jump to the location. Which location we are supposed to see? We have to see the 80th location. So because the operating system which is loaded in the 80th location onwards, in the previous program wherein the X register was initialized into 80. So from that location onwards, the object program is loaded. That is the reason when the process is done, once the end of the program is reached, then jump to the location which is mentioned in the constant, that is 80. Else, if it is not equal to, so if it is not reached the end of the program, what needs to be done is the a value has to be compared with the value 48. So it has to be compared with the value. So it is compared with the hexadecimal value. So when it compared, if suppose the value is less than, okay. So if the value is less than, then JLT. So JLT is if the condition, when you compare the value present in the accumulator and the value given in the constant, when you compare these, if the value present in the accumulator is less than, then sorry for the inconvenience. So when there is a value which is compared with the value in the constant, that is operand, if the value in accumulator is less than that value, then what happens is it calls the getC function. That is why in the JLT, if the condition code has the value less than, which is derived from the previous statement, and jump to the getC so that it will be reading the next character. Else, if not, if suppose the value is not less than the constant, then subtract from 48. So when you subtract, the result is stored again in the accumulator. Now again we can see that the comparison is taking place. So the a value will be compared with the constant 10. So if the constant in accumulator is less than the 10, then it will return. Otherwise, what will happen is, if not, then it will go to, suppose if the value is not less than 10, then the next step would be, it will be subtracting the value by 7. So after that, once it is done, this is all happening for the conversion process. When any character is read from the object program, so it has to be converted into the internal representation. So in most of the cases in the loader algorithm, whenever we discussed about the absolute loader or the linking loader, if you could have noticed that whenever you try to load the program, the object program into the memory, that time when the object code is in the character format, it has to be converted into the internal representation and it has to be loaded into the memory. The same thing happening here. So in the getC subroutines, it's not only reading the character and also it does the conversion. That is what the conversion process will be happening in this few instruction set. So that is the reason the comparison happens and the jump instructions will be called. Once this is done, then it will return. So R sub is the return from the subroutine. So JSUB is used to invoke the subroutine. That means jump to the subroutine whenever it jumps to the subroutine where it has to come back after completing the subroutine, where it has to come back. That address will be stored in the L register. So in the beginning of the chapter, in the first few chapters, I was mentioning about the different registers in SAC and SAC-XC, wherein I have told you about the linkage register. Linkage register used in the subroutine. When the subroutine is called, so after completing the subroutine, where the control is transferred back, so where it has to come, which location it has to come back, that is given in the linkage register. So when RSub is called, so automatically the call has to return back to the location which is mentioned in the linkage register. So this is the end. Once it is done, that is the ender. Then it will go back to the main program and it follows the remaining things. So JSUB will be called. Then it will continue once it is coming back to the statement after the loop. Then it continues with the remaining things like loading the once the conversion is also done, loading into the respective locations and keep implementing the address and then again calling the subroutine. So this process will be repeated till reaches the end of the program. Once it is reaching the end of the file, then the jump instructions will be used again in order to jump to the location 80. So which is used to start the execution of the program. So this is how the Bootstrap loader will be used to load the object program into the memory and starts the execution of the object program. So this is what how it loads the operating system into the memory. So for the conversion, I have given you already how the conversion is taking place. So it is checking with the value 48 and also it is checking with the value 10. So if the value is less than 48, then it will go for next character. If it is greater than 48, then it has to be subtracted. Similarly, when it is checked with 10, if it is less than 10, then the binary format will be represented. Otherwise, again, it has to be subtracted by 7. So that finally the binary format will be there. So in both the characters, if you look at 1 and C, so these two characters are read from the object program and this form one single byte and that will be stored in the respective place in memory. So this is what the use of the getC subroutine to read and do the conversion, and it is returning to the main program, that is returning to this program, so that it loads the particular byte into the respective place. So this is the use of the Bootstrap loader. So with this, I'll be ending the session.